So thank you everyone again for joining us for our first DevSec For Scale meetup. We're really happy to have you. We have two great guests who I'll introduce in just a little bit. Before we get to that, a little bit about the agenda. I'm going to give a quick introduction about the meetup group / the community, what we're trying to achieve. I'm going to talk a little bit about the company that I work for, just to give you an intro there. And we're going to start our two talks. One is about ensuring Terraform HCL best practices, and the second talk is about security, just common tools and best practices for IAC. So moving forward here, the DevSec For Scale community, we're really excited to get this off the ground. And our priority is making security a first-class citizen in young and growing companies. And as part of that, what we realized is, there's this gap that we see in terms of security where growing companies, startups, young, early stage companies really have a harder time integrating security in their workflows, in their SDLC and everything like that, because they don't necessarily have a CISO yet. They don't necessarily have security engineering, ready. So with that, part of what we want to do is try to bring together DevOps, security, IT, InfoSec people, talk about the challenges for early stage companies and growth companies, and figure out ways that we can ensure that developers are able to implement security best practices while not interrupting their usual life cycles and preparing for their MVPs. So with that, to that end, we have this meetup group that we started, and we also have a podcast, DevSec For Scale podcast. You're welcome to go ahead and search that on Google. More than happy to have any listeners, and of course, anyone out there who wants to join, has something to say, please feel free to email me. It's jeremy@achilles.io. More than happy to talk to you and have you on the podcast. Very quickly about Achilles, we're a leading enterprise grade solution for secrets orchestration. So that's what we do, secrets orchestration. And I put a link in here to the meetup group so anyone can see and click into it and join. And also definitely more than welcome to jump into our website. And from there, feel free to get started with our product. It's a SaaS based solution. So you don't have to deploy anything. You just go ahead, go to the console, register, and you have a, production ready secrets vault. And that's it. That's what we do in a real small nutshell. All right, getting to the actual meetup event. So securing infrastructure as code. First, we have Sefi Genis. Sefi is the co-founder and CTO at a really cool startup called Firefly. And he'll give us a little introduction, I'm sure, as well. And he's going to be talking about a cool open source project that Firefly just released recently. Really excited for that one. And one of my friends, Dan Yelovitch, who is part of the DevOps Days Tel Aviv organizing team along with me. So Dan, great to have you as well. And he's going to be talking about some tools and best practices for IAC as well. And he's a DevOps architect at develeap. So thanks everybody for joining. And with that, Sefi, I'm going to hand it over to you. I think I have there was someone who I think raised their hand. Let me see if I can pull up that information here. Let's see. I'm going to stop sharing.
Okay.
No, we don't have a hand up. So Sefi,
so I'm
all yours.
I start. Great. Thank you very much, Jeremy. Thanks for organizing this amazing meetup. So now I'm going to talk about ensuring HCL best practices and open source. So as mentioned before, I'm Sefi Genis, CTO and co-founder at Firefly, love Schnitzel, Ninja Warriors, and InfrastructureasCode. But seriously, I served in Unit 8200 in the Israeli military. I worked for a few startup companies. The most significant one is Dominant Security, that was acquired by Checkpoint. I worked there for 4 years. After Dom9, I worked as the VP R&D of an Israeli startup company called Synamics. And 1.5 years ago, I established a Firefly. So two sentences about Firefly. We build cloud asset management solution that brings the cloud up to code. It means that we scan the entire cloud footprint and Kubernetes cluster, and we codify everything to infrastructure as code, such as Terraform, Pulumi, CloudFormation, etc. And using our technology, we find drifts between the IAC and the cloud, and we build insights and build more about it. Okay, so why do we need an HCL checker? So, all of you know that Terraform is challenging. Most of you heard about the shift left approach. Shift left means that instead of creating resources in the cloud manually with ClickOps, we use infrastructure as code and deploy everything using code. And this trend started a few years ago. And the reason for that is, first of all, immutability and security and cost. Immutability means the ability to create a group of resources and deploy them into multi-environments, such as staging, production, train, etc. And security and cost, of course, before the shift left approach, you couldn't find issues and problems before the real time, before the cloud. Now we have open source tools such as InfraCost and ATFSec that I'm going to expand about them that verify all of those issues before the CI/CD pipeline. The second thing is technical skills. I am a developer. I have experience in Go, in Python, in Node.js, but learning Terraform was difficult for me. It's the difference between imperative and declarative language. And I'm pretty sure that many developers, it's challenging for many developers to study Terraform. One more thing is the variety of open source tools. Here, you can find 7 open source that comply best practices. Some of them uses for cost, the others for security, etc. But you need to deep dive into each of them to configure them, and it's difficult. And the last thing is about drifts and unexpected changes. Imagine that you write infrastructure as code, you deploy something, but someone has changed your, for example, a security group in the cloud and open it to the entire world. It's dangerous. And in Firefly, we work a lot with drifts and we find them and mitigate them. I'm not going to expand much about it in this presentation, but after that, I would love to talk about it. Okay, so today I'm going to introduce ValidIaC, which we pronounce ValidIaC. ValidIaC is an open source tool that we have launched 2 weeks ago. It's an all-in-one HCL checker that combines few open source and verify best practices. It means that instead of running a TFSec, TFLink, InfraCost, and InfraMap, and deep diving into each of them, you can run ValidIaC, and it's one place to run all of those open source. Our solution is a browser base that looks like that. I'm going to show you the browser-based and the CLI, validiac.com, and it's really easy, really to use, easy to use. So why did I decide to build ValidIaC? First of all, I felt the pain. I'm a CTO. It's important for me to write code to comply best practices. And I set them up. I set all the open source tools up in my CI/CD pipeline, and I deep dived into them. And it was difficult. And I saw that the Kubernetes community, they have open source called ValidCube that's pretty much doing the same for Kubernetes. And I wonder why our community, why don't we have a tool like that can help us and to validate everything in one place. And by the way, I saw my customers struggling with best practices. So that's why I decided to contribute to the community and build ValidIaC. And now I'm going to show you the code. I'm going to deep dive into this lint security cost map. So lint, we use TFLint. TFLint is an open source tool that uses static code analysis to find best practices on open source. You can find using TFLint wrong naming convention, missing tags, invalid instance type, and etc. And I'm going to run it in my local machine. I want to show you the CLI. So I prepared a few examples here that I'm going to run. You can see that I'm going to create an API gateway that the name is actually invalid. And imagine that now you want to deploy it using Terraform. So you run the Terraform plan command, it passed, and now you wait until the Terraform apply will also pass, and it fails. TF-lint helps us to detect issues like that before. So it's very easy to run the linter. And as you can see, this one is invalid and it blocks us before the CI/CD. I have more examples of Azure, AWS, and GCP. In all of them, I'm trying to create a virtual machine. In Azure, I'm creating a virtual machine with a wrong size. This one does not exist. In AWS, I'm trying to create an EC2 in a wrong family. This one basically doesn't work. And GCP, I'm trying to create an instance, VM instance from a wrong machine. And it looks like that. Very easy to run. You can see that it points us to the problem. Two more examples, and I'll move to the second phase. This one is an S3 bucket with a wrong region, US East 4. Most of you know that there is nothing like that. And policy too long. This one is a really interesting example. I tried a few weeks ago to build a huge policy, and I failed because we have limitation in the cloud. And you will find this limitation just while trying to Terraform apply, just while trying to apply it. So ValidIaC basically can check it. And now, as you can see, it points us to the problem. It shows that the policy is too long. Okay, so the second thing that I want to talk about is the security TFSec. TFSec is a static code analysis tool that was created by Aqua Security. TFSec validates compliance, security vulnerability, and network security misconfigurations. And as you can see here, I have some examples. If, for example, I'm trying to create a user without an MFA configured, or if I'm creating an S3 bucket that is exposed to the entire world, or configuring the security group with a huge scope, so TFSec blocks us. And I'm going to show you the browser-based solution. Here, for example, I'll take, this is an interesting example, list privilege. This privilege means that I'm creating a service, and here I grant S3 get object for all the resources in my account. And if I'm running the TFSec, so as you can see, this is a new line. We'll try a different example. Okay, so it points us to some issues. In that case, I'm creating a blob job in Azure that the TLS is not configured well, and this is a critical issue. Or I gave you an example about I am user without MFA configured. As you can see, this one, this is the result. And I'll give one more example about security group. This one is a security group that is open to entire world in port 22 SSH. And it's something that should not be configured. We need to create a security group with a low scope, just with private IPs. And this one is insecure, and TFSec tells us exactly what is the problem. Okay. One more thing is cost. We use InfraCost. InfraCost is static code analysis that estimates the pricing of resources before deploying them. It can point us to some problems such as huge machines, over-provisioned assets, wrong volume, I'm going to show you an example that I had in my previous company. We worked with a contractor that created an EBS volume without fully understand what is IOPS, and it didn't know that if I'm creating EBS volume with the total size of 50,000 is going to cost $5,000, and it's expensive. But I saw something worse, something bad. This one is an example of a dynamo table that I configured the read-write capacity to a huge number. And as you can see, the pricing is going to be $56,000 a month. And InfraCost helps us to detect issues like that. And of course, you can find if your machine is too low, is too large, it detects it. The last thing is InfraMap. Here, I'm going to show you an example from Azure. In Azure, if we want to create a single server, single virtual machine, we need to create a network interface, a subnet, a virtual network, etc. And we can forget to connect something. And InfraMap, it's a static code analysis tool that basically it's a static code analysis tool that basically generates the map with all the connections. So now I'm going to show you this. One moment. Okay, so it's automatically generate the connection between resources, and if we forget to connect between the virtual machine and the resource group, so it points us to issues like that. And it's really cool and easy. So the key takeaways: HCL is not a bad word. We should all use Terraform and use best practices. Firefly decided to contribute to the community, and we are here for you. We'd love to get some feedback, and you are more than welcome to open issues and support us in GitHub. And thank you so much. Do you have any questions, someone?
Thanks so much for that, Sefi. It looks like nobody here has questions, but I do have one question, actually. ValidIaC, what about tools like TerraGrunt? Does ValidIaC support TerraGrunt?
Yes, it's a good question. TerraGrunt, basically, it's an orchestrator above Terraform. And I also prepared an example. I'm going to share my screen.
Look at that.
Just a moment, please. Great. So as you can see, here I created the TerraGrunt solution. TerraGrunt concept is dry, don't repeat yourself. It means that we're modeling my code, and I don't want to recreate. I want to reuse my code. And here I'll run, for example, ATFSec, the security, on my TerraGrunt project. And as you can see, we detected 4 different problems because in my TerraGrunt project, I am trying to create a role with a policy with too much permissions. So it works.
Perfect. That's awesome. Sefi, thank you so much for that talk. And Dan, do we have you on the line?
Yes. Unfortunately, I need to be host in order to turn on the video again.
I can do that. I have the power. So
yes.
I made you the host. Go ahead and share away.
Okay. Thank you very much. And thanks to you very much, Sefi. It was a very interesting talk, and I can't wait to test out the tool myself.
Thank you so much.
So now I'll share my screen. And good evening, everybody. Yes, let's start presenting. Hello, my name is Yelovitch, and today I'm going to be talking about security and infrastructure as code world. I'm going to talk about some of the best tools that we have and some of the best practices. And first thing about me, currently my role is an architect in develeap, which is a DevOps consulting company, and had the privilege of working on many projects in companies both big and small, and in clouds of Azure and Google and Amazon and whatever you want, and on-prem. So I have a lot of experience with things that I've seen. And then I'm not going to be talking about tools. I'm going to mostly be telling you stories. So I hope you don't bore you too much. And that's a fun. And if you have any questions, feel free to ask away in the chat. I'll try to keep track of that. So first thing, infrastructure as code. Yeah, it's a big word. And let's try to chat out. Anybody can give me a name of a tool that uses infrastructure as code. And you can use Terraform.
Ooh, we had a question to Sefi, I see.
Oh.
We'll get around to it afterwards when you're done.
Yes.
Okay.
Go ahead. But
So,
I'll add Jenkins.
Oh, okay. I don't see that. I just see chat to everyone. Yeah, but Jenkins is infrastructure as code. Okay, so no, just a moment. Let me close that. Okay, so what do I see as infrastructure as code? What are the main things that we get from it? For me, it's the three S's. It gives us a system that is scalable, it's simple, and it is secure. And that is the great benefit of using tools as infrastructure as code, and that's why we want to use it as much as we can. And the important thing that I learned while researching this talk is I learned that Snyk, a very nice company, had an infrastructure as code report of 2021. And in it, two very important numbers came out. One thing is 63% of the companies said they use infrastructure as code in some sort of way. And 7% of the company in their report said that they use it well in all the system and they adhere to best practices. Now, this is very interesting for me for two reasons. First thing, it means infrastructure as code is here and it's going to stay here. Most of the companies use it. And as more and more developers and engineers move between companies, more and more companies will be using it in the future. But it's still in the infancy. As you can see, a lot of companies use it, but don't use it well. So we have the privilege of right now doing it well in our programs, in our companies. Using it well means building the foundation right. If you build the foundation right, if you build the security right from the start, then you don't need to do any more patches. Because look at this state of house. Something is wrong with the foundation, and we did a patch on a patch on a patch. I'm sure it will be secure, but will it be simple? I don't think so. Will it be scalable? No. But if we build it right from the start, and we use the best practices from the start, then it has all the three assets that I like. So now let's talk about security. Security is usually, when we think about it, it's hackers, anonymous guys sitting in the dark with their hoodie on and the sunglasses on and the code is flying on their face. Yes, there are external threats for security, but this is not the only thing that we need to protect from. The next thing we need to protect from is internal. And I'm not talking about malicious or something that somebody's trying to harm us, but accidents. People who don't know how to use the system and use it in a way that it's not intended to and cause the breakdown. Now, most of the things that we see that shut down the system is not external. It's mostly internal. So we need to be secure from both without and within. Now, the truth about security is that it's boring. It is really boring. The only time security is exciting is either you're doing something wrong or you're in a Hollywood movie. And these are not the cases in most time. And because it's boring, let's be frank, I don't want to mess with it right now. I don't want to handle it. I want to have someone else handle it. I need to get the developers on it. I need to get the management on it. How do I do that? Well, in my time in develeap, I learned one thing that works really well and how to get people to work with you. Talk to them. Don't just tell them what to do. Explain to them why you want to do it. I can tell you right now, the number of startups that I saw that did not have any VPN and the database was on public IP without any firewall, the number was staggering. Like every other company was like that. And I could tell them, hey, put VPN right away. And we'll tell me, why? We don't need it right now. Everything is working. We don't need any to spend more money on it. But if I told them the risk, if I told them, yes, you are now prone to attack. Somebody can attack you, somebody can shut down your system, and will look bad to investors, suddenly they're with me. If I tell to developers, don't use the password everywhere, they say, wow, it's working. But if I tell them the risk, they will work with me. And that way, we can get a more secure system together, and it will be less of a chore for us. So now let's talk about the danger that I've seen and the solutions for them. Now, I want to say up front, I'm going to talk about 2 tools, but this talk is not about the tools. This talk is about the methodology behind the tools, the reason for them. So if you see another tool that you can use, if you can write another tool, cool, send me a message. I want to check it out as well. Okay? So first thing we're going to talk about is secrets. Who can tell me types of secrets? And I think I'm in the right chat for that. Who can tell me type of secrets? Let's see who can share.
You're definitely in the right place, Dan. Can you make me the head of the what's it called, the admin again?
Yes.
show my face. Actually, that is actually what a keyless deals with. So we go with passwords, API keys, SSH keys, tokens, and any other kind of credential. How's that?
Yeah, we got that. Yes.
I got them almost all of them. Yeah. Okay.
I think there are a few more, but again, let me tell you a story because that's what I like to do. So previously, I worked in a previous company that had to do a merger with another company. And part of the merger, we had to do some changes to the Git repo. And one day, by mistake, accidentally, I changed the Git repo to be public for 5 seconds. And then I changed it back. Immediately, so I felt, okay, nobody caught it. It's okay. But then a few services stopped working. And then I got an email from AWS saying, your AWS credentials have become public. We have shut them down, and please recreate them. And I'm saying, okay, that's probably what happened to the services. I recreated the AWS credentials. Everything was working. But then I got myself thinking, where are the AWS credentials? Because we are checking the code. I had a tool that scans the code for passwords. What happened here? And then I understood that I'm working with Git, and the passwords are not only in the code, but there's also the history and the branches. And I started scanning the Git for all the history. And my God, the things that I found. Yes, AWS credentials, database password, SSH keys. I think social security for some reason, I don't know, everything was there. So the good thing about this is we found everything. The bad thing about this is that we spend around 5 days just finding out credentials, revoking them, and recreating them just to get everything working. So what did we learn from this? How can we solve this? The solution is use a keyless. Yes, it's a great solution as a vault. Again, I'm not here to promote a tool, but the thing is secrets have their own life cycle, and they have to be stored in a special place. If you're an AWS, use AWS Secret Manager. If you're a GCP, Google Secret Manager. If you're an Azure, Azure Secret Manager. The names are not very cunning, but they do the job. And again, if you want something cross-cloud, use Terraform, use a keyless, use whatever you want. I also use the Spectral tool to scan our code continuously. Whatever it is, you always have to be vigilant that people will share the secrets. And if they do, you immediately have to alert them on it and revoke the secret as fast as possible. Another problem that we have is complexity. Infrastructure as code is, as the name implies, code. A code grows more complex as time passes. You have more and more offers, more and more people with their own personal style, and things grow and grow. Hopefully, as the company grows, so does the code. So now let me tell you a story. And we have a guest here who participated in this story. So welcome, Jonathan. And what we had is in Develop, we had a company that had a product. And the product was made up of 40 different services. And each service constituted dozens of AWS resources. And I'm talking about Route 53, S3, EC2, Fargate, EKF, I don't know, it had everything. And it was written really, really well. Like Terraform was written really, really well. But they had a problem. The product was located in a single region in the United States, and they wanted to move to a different region, to Europe. And when they started doing that, it took them 6 months to try to build a new site. 6 months for infrastructure as code. People cried, people quit, things broke down. It was horrible. So they called developing, they asked us, please look at this code, tell us how we can do it in less than 2 weeks. And yes, we got the job done. Now you ask, why is this complexity a security issue? Now, later on, when I found out that their main product that was in the United States wasn't as stable as they said, it was continually breaking down. Every time somebody made a small change, the things that were dependent on so many resources broke down, and the team, instead of making sure that the infrastructure was correct, always made sure that to put out fires. So we played whack-a-mole with infrastructure, and in the end, you wouldn't get to the bottom of it because you would have more and more problems and not enough developers to solve it. So complexity is an issue, and when the system is fragile, accidents will happen. Now, how did we solve it? By reading this book, which I strongly suggest. No, we didn't read this book specifically, but I, in my youth, read this book, and I strongly suggest it to everybody. And if I can summarize this book in one sentence, is treat your code as a book. Make it readable. And I gotta say, this book is one of the more readable books about computers that I ever read. But the thing is, what we spent the next few months understanding the code that happened there and making it readable, using modules, using Terraform, using hierarchy, using whatever we needed to make the code cleaner, and then having someone who doesn't even understand Terraform understand what he's deploying. And once we got that working, everything was flowing from there. We can make the changes, we can move the code without harming anyone, and the product itself became more and more stable. Now, the next problem that we have is blast radius. I just love saying that word, blast radius, meaning the things that we can do without intending to. So now again, I'm going to be telling the story, this time about my youth, and the first time I met an EC2 computer on Amazon. So I was a really young programmer, and my boss asked me, here's an EC2, here's a Linux, I want you to install GPU drivers on that. I don't know if many of you have done this, but it's really, really not easy. And I worked on it all day, and in the end, I got so frustrated. I just wanted to start everything anew. I didn't know anything about EC2, so I did RM, RF, root. It cleaned the computer, but it also makes it completely unusable. Luckily, I was working on EC2 on a machine that was that was containerized for me. So that's the thing that we need to worry about blast radius. When you give someone permission, you need to be well-defined on what they can do. Now, a sentence that I heard when I was young is, between two well-structured lines, there's infinite freedom to do actions. And that's what we need to do. We need to define the borders of what we can do. If we're talking about Terraform, yes, use IAM roles, but define what they can do. Never use asterisks or something like that. If you're talking about EC2, allow developers access only to that EC2. Or even if we're talking about Ansible playbooks. Ansible playbooks are very, very powerful. We need to know where they can run and be explicit on where we allow them to run, so that they can run on machines that they are not allowed to. Now, the next issue is drift. And I'm not only talking about drift because I really love this little picture of others holding hands while they're sleeping in order to avoid drift. Drift is a real problem in our code. We talked about drift in the previous talk, but drift is basically when I have infrastructure as code, when I have the source of truth, and the environment on which I rely on changes without changing the infrastructure as code. Why is that a security issue? Well, first thing, I'm going to tell you a story because that's what I love to do. And when I started at a different company, the first thing they asked me is take this code, add a new feature, add a new lifecycle policy to an S3 bucket. Sounds very simple, right? Simple Terraform. I did a few changes. I did Terraform plan. I expected one change. I got 140, meaning that if I did Terraform apply, I would change 140 different resources in ways I did not understand. I was afraid of that, and wrongly so. And I did a Terraform plan with a target in order to apply only my changes. This thing makes the system a lot more vulnerable because now we don't know what is happening in it. Furthermore, people can maliciously enter this code and put their own resource and have them run without us knowing about it. And what's more, even more dangerous is someone who is not afraid as me can go and do a Terraform plan and Terraform apply and break the whole system. Accidents will happen. How do we solve it? We make the system self-healing. Self-healing is basically a property of GitOps that says the system needs to apply, the source of truth is Git, and the system needs to adhere to that source of truth. Now, you have several tools like Argo CD that perform this self-healing function continuously. Argo CD, if it will see a change in the Kubernetes cluster that you have that has not been done by Git, it will destroy the change and revert it. Other things that we did, and we did something in another project, is we made all resources created by Terraform have a tag that's called created by with the value of Terraform. Not something very complex. But the cool thing is we had a Lambda that listened on the stream of created object. And if it saw if an object was created without that tag, it automatically destroyed it and sent us an email. So if anybody created a resource without us knowing it, it was destroyed. Now, this Lambda didn't know about any changes, but this is a step in the right direction. And more tools can help you create the environment to be more self-healing. Now, a good thing about security is that good security will eventually break. Something will break in the system. The system is not 100% up. Always have a backup. That's the solution to most of the security problems. Somebody broke the system. Okay, you have a backup, you can restore it. Hackers attack the system and enter the code malicious code. Okay, you can back up the system and remove the code. Always have a backup. It's the best solution to most of our problems. Thank you very much. And if you have any questions, please share.
Great talk, Dan. Great stories. It's always good to have a storyteller because it keeps the attention, and people, I think, really enjoy hearing about these things, especially times where, things don't actually go to plan, right? So thank you very much for that. I think we had a really, really great time. I'll ask one question that I was wondering about is, how would one go about choosing, or the best tool or, any tool, let's say, to secure infrastructure as code?
That's a really good question. I said there's not a single rule of thumb, but I would say use your community. And we are not alone in this world. We have a very strong DevOps community around us. Feel free to ask questions. And even if you choose a tool from GitHub or whatever, look at the number of followers. It's like the number of stars on a product in Amazon. Look at the number of followers, look at the number of forks, number of merge requests, when you know how popular the tool is, how well maintained it is, and when you can choose it. I saw a lot of people use tools that had 3 followers, and then it broke down and nobody could help them. So be careful with that. Okay, and thank you very much. It's been great talking to you. If you have any question, this is my mail. Feel free to send me a line and I'll be happy to help you.
Wonderful. Thank you, Sefi. Thank you, Dan. Really, really appreciate both of you joining us. Sefi, I know you can't open up your camera right now because I didn't make you the host. I don't know why Zoom has to do this. You may have to change platforms because of this. Thank you very much to everyone who joined us. We really had a great time. We kept it, I think, pretty short and sweet. No hour-and-a-half, 2-hour-long meetup sessions and all that. Very precise, great talks. So thank you very much. And if anybody has any questions for these two, you're more than welcome to reach out to them personally. And you can reach out to me, jeremy@achilles.io. Really, really grateful to everyone for coming, and we hope that you can join us in our future meetups and events and podcasts. So I look forward to being in touch with everybody, and Dan and Sefi, we will see you guys again hopefully soon. So thanks so much. Have a great night and day wherever you are. Thanks, everybody.
Thank you so much.